Hi, welcome back to McClatchy Maths. My name is Natalie McClatchy, and in this video we are talking about the unit circle, which forms part of our trigonometry series. And in this particular video you are going to find out what the unit circle is. We'll look at a couple of quick worked examples, talk about what's coming up in future videos, and talk about how to engage further with the McClatchy Maths channel. So hopefully you have watched our previous video, which talks about exact values of trigonometry. That's an important precursor to this particular video. Now, so far in this whole trigonometry series, we've only been looking at acute angles. These are angles less than 90 degrees. We haven't really looked at any obtuse angles and talked about how to find their exact values. So we are going to be looking at obtuse angles mainly in this particular video. So we're going to look at those. They are going to be in the range from 0 degrees all the way up to 360 degrees because we're talking about a unit circle, and a circle has 360 degrees. So to do this, what we're going to do is start with something called the unit circle, which has 4 quadrants. Okay, so these are quadrant 1, quadrant 2, quadrant 3, quadrant 4. And you'll notice that each of these quadrants breaks the circle into quarters, and each of these quarters, the two different crossbars, are at 90 degrees to one another. Now you'll notice that the conventions for naming the quadrants goes round anti-clockwise, and the reason for that, it's a bit of a weird reason. It all goes back to ancient Babylon, who invented the unit circle and a lot of what we do with trigonometry today. We don't know why they named it anti-clockwise. It's just a naming convention. It's nothing more. But it is important that you remember what each quadrant is called, because that will affect your different values for sine, cosine, and tangent. So let's get into that now a little bit more deeply. So we're going to take that cross that was in the middle of our circle. We're now going to imagine that that forms the x and y axis of the Cartesian plane. This is going to become even more important in our future videos. So we're going to call that x and y. Now we've got our origin. That's going to be with the coordinates of 0, 0, right in the middle where the two x's and the y-axis meet. Okay, now what we're going to do is assume that our circle has a radius of 1. And that's why we call it the unit circle, 1 unit. Okay, so we've put 1 as our value for our radius. Now we're going to look at all of those angles, and we're going to call that angle theta. And we're going to calculate their size using our x-axis, and we're going to go in an anti-clockwise, or if you're looking on the internet, if you're in America, you'll probably call it a counter-clockwise direction. And so we're going to be going away towards the second quadrant and the third quadrant. It's heading in a positive direction all the way up through positive x and y values towards negative x values. So we're going to start from here and work our way up there. Those are the kind of angles we're looking at here. So we're going to pick a random point on our circumference. We're just going to call it P, P for point. Nothing special about that. Now this point P, we don't know its coordinates, okay? So we're just going to call them x and y. Now obviously, because our circle has a radius of 1, then the value of x and the value of y are going to be less than 1. So in other words, we're looking at our horizontal distance of P from the y-axis. That horizontal distance out is going to be the value of x, and the vertical distance using our x-axis, so that's the distance in this direction, is going to be a distance of y, and that's where we get our coordinate values of x and y from. Okay, now let's consider the size of the angle that P is going to make with the origin here. So we're going to make a right-angled triangle, and we've got that radius extending up to P, and we've got part of a radius extending out to x and y, and that forms an angle theta with the x-axis. Now our distance from the origin to P is also going to be 1, because P makes a radius with the center of the circle. So it's also going to have a value of 1 in the unit circle. And as we mentioned before, that's our hypotenuse. So that means that the length to x and the height to y is going to be less than 1. Okay. Now we know that the formula for sine of an angle is opposite over hypotenuse. We've looked at that in previous videos. So now if we substitute some information from our unit circle into the formula, we've got an hypotenuse of 1 we've got the length of the opposite side, which opposite to theta is going to be that height of y. So if we substitute that in, sine of theta is going to be y over 1 or just y. So now we've got a value sine theta equals y. Whatever that length of y is, that's what the value of sine theta is going to be. And the cosine of an angle is going to be cosine theta equals adjacent over hypotenuse. We know that from year 9 trigonometry. So let's substitute some values out of our unit circle into this particular formula. We've got that hypotenuse again of 1, and we know that the length of the adjacent side is going to be x. So if we substitute that into the formula, we're going to get cos theta equals x over 1 or just x. So we've got a value for sine theta of y and a value of cosine theta of x. Now we know for tan theta is the opposite over the adjacent. So that means the length of the opposite side is y and the length of the adjacent side is x. So tan theta equals y over x. And we already worked out that y was equal to sine theta and x was equal to cosine theta. So tan theta equals sine theta over cosine theta. And we saw a little bit of that coming out in our previous video, and we talked about our finger rule and our hand rule. If you haven't watched that one, do go back and have a look. We sort of evaluated that tan theta was going to be equal to sine theta over cosine theta. Okay, that's an important formula to remember. So if y is equal to sine theta and x equals cosine theta, then the coordinates of P must be cosine theta, sine theta. Okay, so that's our coordinates for those different ones, because remember we said the coordinates were x and y. So therefore, if we replace x with a cosine theta and y with a sine theta, then we've got these coordinates for our point P. Now this means because we've got coordinates of the point P, we can actually work out the coordinates of any point on the circumference of the unit circle if we know the angle, or vice versa. So that's a little bit of future work there. But today we're more interested in just the value of the angle of that particular one. So now we need to talk a little bit about angles in each quadrant. So there's some things you need to memorize about the sign of the angles in each quadrant. And I've got a table here. You might want to pause the video now and copy this down. So in the first quadrant, the sine of the angle is going to, and the cosine of the angle and the tan of the angle is all going to be positive answers. And the reason for that, we know that we've been working with acute angles so far. Whenever we find the sine of 30 degrees, if you remember from our previous value with exact values, the sine of 30 was a positive number. The cosine of 30 or the cosine of 60 was a positive number, and so on. So in that first quadrant, they're always positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cosine is positive. Now, you might think, how on earth that looks confusing. How am I going to remember this? Well, there is lots of different mnemonics on the internet. Your teacher might be able to help you with a different one. You just remember the mnemonic ASTC, and I've put words around that. All students take classes. So that, remember, in that order, A for all, quadrant 1, all of them are positive. S, quadrant 2, only sine's positive. Quadrant 3, T, so take the classes. And in quadrant 4, only C is positive, and that's your cosine. So if you just need to remember the mnemonic, and that helps you remember what angle is going to be positive in which quadrant. Okay, so that's our first thing we have to memorize. So you might want to wonder, but why is that so? Why is for example, cosine only positive in quadrant 4, or why is tan only positive in quadrant 3? Let's have a look just at the second quadrant, and the principle will follow to the other two quadrants as well. So let's think about sine and cosine. What's happening to them in that second quadrant where sine is positive and cosine is negative? So let's now have a look again at our unit circle. We've got point P. At the moment it's in quadrant 1. Let's move it over to quadrant 2. Now the length of x is going to be the same. But this time you can see if we're talking about x and y axis, it's on the negative x axis. Y is still in the positive y axis. So that's where the Cartesian plane is important to think about. So if we think about that now, cos theta was equal to x, sine theta was equal to y. Now if we think about x being a negative number, then cos of theta will be negative in that quadrant, but the sine of theta will not be, because y is still a positive number. And it follows as we move around that unit circle, when we move into that third quadrant, for example, we're going to have x and y being negative numbers on the Cartesian plane. When we move into the fourth quadrant, we've got y as negative numbers, but x as positive numbers. Now for 10, it's a little bit different because it's all about negatives dividing by negatives and positives dividing by positives. For example, tan theta, sine theta equals sine theta divided by cosine of theta is our value for tan theta. If one of those is negative, tan theta is going to be negative also. And that's because a negative divided by a positive is negative, or a positive divided by a negative gives us a negative number. However, when we've got negative divided by negative, and we've got the one quadrant, quadrant 3, where both sine and cosine are negative numbers, negative divided by negative gives a positive, and that's why tan is a positive in quadrant 3. So now if we think about the size of the angles, so this is an important one too. So we've got quadrant 2 and we've got quadrant 1 at the moment, showing those two little right angled triangles. Let's think about the size of theta. We're interested in that size of the angle that's formed from the positive x-axis all the way to the OP arc in quadrant 2. So that's that angle in there. So obviously when we were looking in quadrant 1 only, acute angles only, but now we're looking at an obtuse angle. We want to know what is the size of that angle. So it's going to be equal to 180 degrees less theta, and that's because that x-axis here forms a straight line of 180 degrees. Take away this angle theta here will give us this angle here. So that's a nice easy way to remember it. These two triangles are exactly mirrored in the unit circle. So if we take this angle here, 180 degrees, take away that, we'll get that obtuse angle. So for example, let's use some real numbers. Let's say theta was 50 degrees in quadrant 1. Well, in quadrant 2, it's going to be equal to 180. Take away the 50 degrees because it's the same triangle. So we'll end up with this 130 degrees. So what that means then is that sine 50 and sine 130 are both going to be positive because remember, all students take classes in the second quadrant, sine is positive. So sine theta equals sine 150. You can try it on your calculator and see if it works. It does work. Just make sure you're in degrees mode. However, when you're looking at cos 130, remember cos 130 is the opposite sign because ASTC in the second quadrant, cosine is a negative number. So if I ask you for the cos of 130, it's going to be equal to negative cos of 50, or the cos of 50 would be equal to negative cos 130. So they're opposite sign and their difference is 100, the 180 take away the value of theta. But what about the third and fourth quadrants, you might be asking? And obviously I've just jumped ahead. You can see that the 50-degree angle originally in quadrant 1, we call that our reference angle because we use that reference angle to calculate the value of the other angles throughout the other quadrants. So let's have a look at what's happening in each of the quadrants. So in quadrant 2, we're looking at an angle between 90 and 180 degrees. So in our first example, we're looking at 150 degree angle that fits in that range. When we move into that third quadrant, the value of our angle as we come around the circle is going to be 180 to 270 degrees. And in the fourth quadrant, our angle size is 270, take away, or to 360 degrees. Okay, now the calculation to come up with the reference angle. So we know our reference angle in quadrant 1. Well, quadrant 2, we've talked about that. It's going to be 180 take away theta. Quadrant 3, we're going to come all the way across to that straight line. So that means that we've already passed through 180 degrees plus the reference angle. And in quadrant 4, we start from 360 and we take away the reference angle. Now, something that people get a little bit confused about with the unit circle is that the quadrants do go anti-clockwise, especially when we've done true bearings. And true bearings, we have to go clockwise. So just remember, this is different to true bearings. Okay, and a lot of the way people manipulate true bearings by taking 360 and taking the angle away and so on to get the true bearing, well, the principles that we follow in the unit circle are not the same principles we follow for true bearings. So try not to get the two confused. I know it's challenging. Okay, let's look at a couple of very quick worked examples now that we've got our core foundation underlying unit circle. So firstly, what is the equivalent angle in quadrant 3 for sine 30 degrees. Sine 30 degrees is our reference angle. We want to find whatever angle falls into quadrant 3. So let's look at our different informations that we had to memorize, our memory tools. So we've got all students take classes. That'll tell us what size the angle is going to be, and how to calculate the equivalent angle is going to be from this table here. Now, I would say, yes, you do need to memorize this table. It might actually just be easy to remember the principle behind the table, and that way that'll save you a bit of memory. Otherwise, just print it out, stick it somewhere safe around the house, bathroom, bedroom wall, next to the mirror, so that you're focusing on learning this information. Okay, now that we've got our memory tools, we are talking about quadrant 3. So we're interested in what's going on in that second box. So to do that, what we're going to be doing is taking our reference angle of 30, adding it to 180. I'm sure you can do that in your head. That's going to give you 210 degrees. Now, to know what size, that's the size of the angle, what's the direction of the angle? Is it negative or is it positive? ASTC. So AST in that third quadrant, only tan is going to be negative. So that only tan is going to be positive. So that means that sine is going to be a negative number. So the equivalent angle in quadrant 3 for sine 30 is going to be sine 210, and it will be a negative sine 210. Try it now on your calculator. Put in sine 30, press the equals button, see what you get, and then type in negative sine 210. You should get the same answer. Okay, now we're going to be writing tan 162 using its reference angle. So to do this, what we're trying to do is find out what is the reference angle. So we know tan 162 because it's between 90 and 180 degrees. It's in that second quadrant. So let's bring up our memory tools again. We're interested in that second quadrant. That's that first box there. So to get our reference angle, we take 180 degrees, take away theta. Now 180 take away the 162 is going to give us our reference angle, and that's going to be 18 degrees. Now remember, tan in the second quadrant, ASTC. The only thing that is positive in that second quadrant is sine. So that means tan is going to be the opposite. So it'll be the opposite sign to the reference angle. Now we've been given tan 162 as a positive number, which means the reference angle will be negative tan 18. Once again, try it on your calculator. Put in tan 162, press equals, then put in negative tan 18. You should get the same answer. So that's why you can verify it on your calculator. So these are some very basic worked examples today for the unit circle. We're going to get into some more complex stuff in our future videos, and that might be something you're wondering about. What is coming up? Well, this particular video forms part of the almost senior syllabus. So if you're doing, for example, in Australia, prep math methods in grade 10, then that's something that you'll be doing with the unit circle. If you're doing your GCSEs in the UK, then you'll be also looking at the unit circle, preparing for your A levels. And if you're doing senior maths in USA, you'll also be looking at the unit circle there. So our future videos are purely for senior mathematics students, not for general maths in Australia, but for math methods. So lots of senior trig coming up in our future video series. And if you found the video helpful, here are some ways you can engage further with our channel and also stay up to date with all of our news and what's coming up. So firstly, tell us. I love to hear your feedback. In fact, I got some fantastic feedback during the week from some students, and it actually brought tears to my eyes. I really do get a massive kick out of helping you all out. So please tell me if you found something helpful. It really, I guess it's payback for the work I put in. It makes my day. Thank you. And you could also tell somebody else. If you've got a friend, a family member, a cousin, someone at your youth group, someone at your scouts group, someone from your church or from your school that you think needs some help with maths, tell them about the channel, and make someone else's day as well. You could also like and subscribe, and that way you're going to stay in touch with everything that's happening on the channel. If you've got questions that are a bit complex, do send them through to mcclutchymaths@yahoo.com, or you could contact me on Facebook or Instagram messaging. And I would like to say thank you so much for our returning subscribers and all of our new viewers that have joined us today. Thank you so much for taking the time to watch McClutchy Maths. I'm Natalie McClutchy. Have a wonderful day.